Okay, we're considering this density curve, and it looks like we're going to be looking for the first quartile, the median, the third quartile, and the interquartile range. So, first things first, since it is a density curve, the area under the curve between 10 and 20 on the x-axis is equal to 1. And what we're being asked for is first the first quartile. To calculate the first quartile, we need to find the x value that has 25% of the area to its left. So I'm looking along the x-axis for some x value where the area to the left there in that triangle is a quarter of the total area between 10 and 20. So I'm looking for a specific x value that represents the 25th percentile or the first quartile. Well, that's a rectangle whose area is 25, and I know area is equal to length times width, and the length in question here is the side-to-side distance would be the distance from 10 to x. So if I can find out what that length is, I'll know how far it is from 10 to the value of x. So that area is 0.25, I already know that. The length is how far x is from 10, and the width is pretty much just the height of this rectangle, which is 0.1 because this is a uniform distribution. So when I do this calculation, I find out that x is equal to, I divide both sides by 0.1, and 0.25 divided by 0.1 is 2.5. That means that at x value is 2.5 units from 10. So the first quartile is 10 plus 2.5. Q1, the first quartile, is equal to 12.5. 12.5 because we're actually starting at 10, and 2.5 is the first quartile beyond 10. Is how much you add to 10 to get to the first quartile. So that was the first quartile. We can do the exact same thing for the median, except for the median, instead of the 25% marker, we're looking for the 50% marker. So here we're looking for that x value that marks 50% to its left. So we're doing the exact same thing. It's going to be 0.5 equals x, and then the height is still 0.1. Height is still 0.1, so I divide both sides by 0.1 here, and I get x is equal to 5. So x is equal to 5. That's 5 units away from 10. So that means that the median, which is also known as the second quartile, the median is 5 units above 10, which is 15. So the median is 15. So there I have the first quartile and the median. Just move them up a little bit. And now it's also asking me for the third quartile. Well, the third quartile, same concept, except now I'm moving my way up to the 75% marker. So instead of 25% or 50% to the left, I'm looking for the x value that has 75% of the data to the left. So the x value separating 75% of the data on the left from 25% on the right. And we do that the same way. It's going to be 0.75 is the area equals the length, which is x, times the width, which is still 0.1. When I divide both sides by 0.1, I get x is equal to 7.5, which I know means that I'm 7.5 units above the beginning of this density curve. So that's 10 plus 7.5, and I find that the third quartile is 17.5. So the third quartile, which is denoted Q3, the third quartile is 17.5. And then the last thing they asked for, so we've answered all these questions. The first quartile is 12.5, the median is 15, the third quartile is 17.5, and now the interquartile range, IQR, the interquartile range is equal to the third quartile minus the first quartile So in our case here, that's equal to 17.5 minus 12.5. So the interquartile range is 5. So that's the answer for the last one there. 5 is the interquartile range.